The universe captivates us with its staggering diversity. It's no wonder why. When we gaze up into the night sky and take in the sparkling constellations, nebulae, and galaxies that stretch across the celestial sphere like glitter on velvet, we're reminded, profoundly and humblingly, of our own smallness. In the face of these countless cosmic wonders, we feel like grains of sand adrift in a cosmic ocean. And yet, as much as the stars dazzle us, there are regions in space that invoke the opposite feeling. Not filled with stars, but rather defined by their absence. These are the dark voids of the universe, vast, seemingly lifeless expanses where galaxies are few and far between, and the oppressive emptiness stretches beyond comprehension. Among these desolate chasms lies one of the most mysterious and largest voids ever discovered. The Boötes Void, a colossal pitch-black region, so immense and barren that it has stirred astronomers' curiosity for decades, and inevitably given rise to bold, sometimes outlandish theories. Some whisper of long-dead civilizations. Others imagine megastructures and intergalactic engineering. But what is the Boötes Void really? Does it represent the ultimate nothingness of space? Or could it, paradoxically, help us answer some of the deepest questions we've ever asked about the nature of a universe? Let's journey deep into the cosmic web and explore the mysteries of the Boötes Void. The cosmic web, understanding the architecture of the universe. To grasp what the Boötes Void truly is, we first need to take a step back and view the universe as a whole. On the largest scales, the cosmos is not a chaotic scatter of galaxies. It has structure. It has shape. Imagine a vast three-dimensional spiderweb stretching across hundreds of millions of light years. This is what scientists call the cosmic web, a massive lattice of matter composed of filaments and voids. The filaments are immense, thread-like formations made of dark matter, gas, and galaxies. They interconnect like the strands of a sponge or the branches of a fractal tree, hosting galaxy clusters and superclusters. Between these filaments lie the voids, immense, cavernous regions where matter is astonishingly scarce. You can visualize this like a soap bubble foam. The walls of the bubbles are the filaments, where galaxies live and thrive. The interiors of the bubbles are the voids, nearly empty of galaxies, dust, and visible light. These voids are not mere background features. They make up over 80% of the volume of the observable universe. And one of the most striking and enigmatic voids ever discovered is Boötes. Meet the Boötes Void, the great cosmic desert. Discovered in 1981 during a redshift survey mapping the distribution of galaxies, the Boötes Void quickly made headlines. Named after the constellation Boötes, where it is located, the void spans an unimaginable 300 million light-years in diameter, an expanse so vast it represents roughly 0.27% of the observable universe's width. If you could place the Milky Way in the center of the Boötes Void, it would take over 150 million years for light from a neighboring galaxy to reach us. To put this in perspective, even though this region is big enough to host over 2,000 galaxies, astronomers have only found about 60. That's a 95% reduction in expected galaxy density, a staggering void in the literal and astronomical sense. If Earth were inside such a void, humanity might never have realized there were other galaxies beyond the Milky Way. The night sky would be so empty, so unremarkable, that the concept of a universe filled with billions of galaxies might have remained undiscovered until the advent of modern telescopes or even beyond. That's the haunting silence of the Boötes Void. Why do voids exist? Peering back to the dawn of time ***. Now the question arises, why does something like the Boötes Void exist at all? To understand that, we must rewind cosmic history. Way back, ** 13.8 billion years ago, ** to the moment of the Big Bang. At the beginning, the universe was hot, dense, and uniform. But quantum fluctuations, tiny variations in density caused by fundamental uncertainty, meant that some regions had just slightly more matter than others. Over billions of years, those slightly denser patches exerted more gravitational pull, drawing in more matter, growing larger. In contrast, the slightly emptier patches lost matter to their denser neighbors and became even more empty over time. This process, known as gravitational instability, gave rise to the large-scale structure of the universe, dense filaments, and the yawning voids between them. Some researchers liken voids to valleys in a mountainous terrain of dark matter. Galaxies reside in the peaks and ridges, the filaments, while the valleys stretch vast and deep. The Boötes Void, then, is not an anomaly. It's a fossilized echo of the early universe's uneven birth, a snapshot of how matter distributed itself as space-time expanded. Alien megastructures or colossal black holes. Unofficial theories about the Boötes Void ***. While the scientific explanation is elegant and well supported, the sheer emptiness of the Boötes Void invites wilder speculation. One popular theory imagines that the void is not natural at all, but the result of alien engineering on a cosmic scale. Enter the Dyson sphere hypothesis, proposed by physicist Freeman Dyson. This idea suggests that an advanced civilization might encase its stars in massive, spherical structures to capture their energy. If this had occurred across thousands of star systems, we might perceive those regions as dark or invisible from Earth. In this theory, the Boötes Void could be a Dyson megaregion, a galactic-scale power grid engineered by an advanced Type 3 civilization on the Kardashev scale. A more extreme idea? That the Boötes Void is a supermassive black hole, a gravity monster so large it swallowed the galaxies themselves. But this runs into trouble fast. Even the largest known black holes, like TON 618, max out at a few hundred billion solar masses, with event horizons mere light-years across. A black hole spanning 300 million light-years would require a mass so impossibly vast, it would break every known law of physics. So while fun to imagine, these theories remain firmly speculative. No observational evidence supports the Dyson sphere scenario or the black hole idea. But the wonder persists. Why the Boötes Void and others like it actually matter. Despite the wild theories, the study of cosmic voids is far from fringe science. Voids serve as critical laboratories for testing our models of the universe. They help us study dark matter, since it influences the formation and shape of voids. Cosmic inflation, the theory that explains how the early universe expanded so rapidly. And even dark energy, because voids can affect how we measure the universe's expansion rate. Voids also let scientists test how galaxies evolve in isolation, far from the gravitational influences of dense clusters. And the Boötes Void is just one part of a much larger puzzle. Other vast voids include the KBC void, our own local underdensity, estimated at nearly 2 billion light-years across, the Sloan Great Wall void, and the Eridanus supervoid, which may even connect to the cold spot in the cosmic microwave background, a possible clue to physics beyond our universe. Conclusion: gazing into the abyss. At the end of the day, the Boötes Void is a place of contrasts. It's a region where there is almost nothing, and yet it teaches us almost everything. From the nature of cosmic expansion to the architecture of the universe to the boundaries of imagination, this great emptiness holds countless secrets. And whether we explain it through gravitational physics or dream of civilizations veiled in shadow, the Boötes Void reminds us of one eternal truth: that the universe in all its depth is as much about what's missing as it is about what's there. Musical note: cue outro music. Majestic, slow build. Alien want more space mysteries, cosmic oddities, and intergalactic what-ifs? Then subscribe, like, and turn on notifications, because the universe isn't done surprising us yet, and neither are we. Thanks for watching. Until next time, keep looking up, ***.